Welcome to you all. Thank you very much for joining us. Tonight we're going to be talking about the EPSRC NERC-funded Aura CDT in offshore wind energy and the environment, and that's the Centre for Doctoral Training in Offshore Wind Energy and Environment. It's a PhD program that is led by the EEI at Hull University in partnership with Durham University, Sheffield and Newcastle University. So tonight we're going to talk about the program and how it works and some of the expectations for our applicants, and then we'll finish off with some questions and answers at the end. Before we get into the main body of the webinar, I would like to invite the director for the CDT to say a few words of welcome. Dan Parsons.
Thanks so much, Danielle. And yeah, I just wanted to convey my warm welcome to everybody attending the webinar this evening. You'll hear from all of my colleagues about this Centre for Doctoral Training, what we're trying to achieve, the structure of the course, how it breaks down, how you have a year's worth of training at the front end that brings everybody into the same sphere of this rapidly growing offshore wind sector, and then you move on to do your 3 years, 3.5 years of research at a chosen institution across the partnership. The program's grown very quickly. This will be our next intake for next year, but we already have a set of cohorts of past 3 years already on the program. You'll get to interact with those, and you'll get to work within and across those cohorts as well, and we bring everybody together to explore everybody's research and what we're all working on. So it leaves me just to pass back to Danielle and the team. I'll be listening in the background should there be any questions towards the end that fall to me to answer. But yeah, just once again, a very warm welcome this evening, and I hope you enjoy the webinar.
Thank you, Dan. So before we progress into the webinar, I'll quickly run through who's joining us this evening on the panel. You've already heard from Professor Dan Parsons, who's the director for the CDT. And there's myself, who is the program manager, Danielle Smith, if I haven't already mentioned myself. I'm also joined by colleagues from Sheffield University, from Durham, and Hull University. So I'd like to ask all of the panel members now to turn their cameras on. And we've also
across the partnership
on the panel with us tonight as well. So if you've got any questions during the webinar, please do feel free to pop them in the question and answer function in the software. I will be picking them up towards the end of the presentation, but as you're listening, if you've got any questions, just pop them in and I'll answer them later, and you can direct them at any of our panel members. So first of all, could I please ask Jim, can you introduce yourself, please?
Hi everyone, I'm Jim Gilbert, Professor of Engineering here at the University of Hull, and I look after industry engagement for the CDT.
Professor Will Coombs.
Hi, so yeah, Will Coombs from Durham University. I'm a professor in the engineering department, and I really manage the transition from the first talk part of the program onto the PhD in terms of selecting your research topics that you'll be doing for the rest of your time with the CDT.
Dr. Nina Deathlefs, can you introduce yourself, please?
Hello, thank you. Yes, I'm a senior lecturer in computer science at the University of Hull. I'm also Aura theme lead for big data, sensors and digitalization, and I'm looking after the admissions process as well at the moment.
Thanks, Nina. Nikos?
Hello everyone, I'm Nikos from University of Sheffield in Mechanical Engineering, and I'm leading from Sheffield's part the Aura CDT, and also I'm looking after aspects of the training program from the CDT. So I welcome you all today.
Thank you, Nikos. Victoria?
So I was already
You'll get to interact with those.
second cohort student, so I've just started my PhD in September.
Okay, thank you. And Daniel.
Hey, I'm Daniel. I'm also part of cohort 2, and I'm just started my first year of my PhD at Hull Uni.
Thank you. I'm just going to check if Maisie is still able to join us. Maisie's not been well, so I'll just double check if she's on the line to say a quick hello. Maisie, you there?
Yeah, I am still here. Still can't get my camera to work.
Hi, Maisie. Do you want to introduce yourself, Maisie?
Second year Aura student, backgrounds in geography and renewable energy.
Thank you very much. So that is our panel for this evening. You'll be hearing from each of the members here at various points during the webinar. And as I said at the end, please do feel free to ask any questions that you might have. So Maria, can we have the next slide, please? So I'm going to kick off tonight and give you a brief welcome and introduction into how the webinar is going to play out this evening. Maria, can we have the next slide, please? So we're going to start off just talking very briefly about why we're interested in offshore wind energy. So this is the focus of the Aura CDT in terms of our research and the people that we work with. So we need to understand why that's important to start with. We're going to run through what we teach as part of the programme. We'll then hear from colleagues to run through what sort of research we're doing, some of the projects that we're doing, and both at the university and in collaboration with some of our industry partners. And then we'll finish off with hearing from the students themselves about their experiences on the programme. And in the last half or the last sort of quarter of the webinar, we'll have some time for some questions and answers at the end from yourselves. So before we push on to the rest of the presentation, I'd like to share with you a short video about why offshore wind we consider offshore wind to be so important.
I'm Daniel Parsons. I'm a professor up at the university, and I'm the director of the Energy and Environment Institute at the university, which seeks to bring together multiple disciplines into one collaborative arena where we can really seek solutions that we in Hull and the Humber really can drive and lead on internationally as we move forward into what's been called a zero carbon world. The Humber is really much at the forefront, on the front line of climate change in a whole host of ways. And when we look at the capacity of wind energy globally, it's exponential. The speed of growth is unbelievable. And that's because the costs have been driven down so quickly. Wind could supply enough energy to sustain the whole of humanity 40 times over. The university and all of the partnerships through Greenport Growth and now the Aura collaborative cluster really coming together, shaping the future of this massive industry, the offshore wind sector. And we're embedded as a region within the UK government's sector deal for offshore wind. We're leading nationally and internationally on this. People are looking at us, at what we're doing in terms of capitalising on the opportunity of offshore wind. The renewable revolution that's happening right here can help address all of these challenges associated with the climate crisis.
Okay, so at this point, I'd like to hand over to Professor Jim Gilbert.
Hi, thank you. So I just wanted to give a quick overview of the structure of the CDT, how it fits together, the different elements that feed into it, and then other people will follow on with a little bit more detail about some of the specifics. So if we go to the next slide, please. So just looking at the big picture, the overall aim of the CDT is really about training future leaders for the offshore wind industry. You know, as you've seen, the offshore wind industry is growing incredibly quickly. It's incredibly important in the UK's transition to a net zero future. And we have a key role to play in delivering that leadership and building up the capacity of the UK and internationally. So the funding that we have received from the Engineering and Physical Sciences Research Council and the National Environment Research Council have allowed us to fund 75 scholarships for PhDs that address these challenges. The way we deliver this is by having a first year taught at the University of Hull around the challenges, the opportunities of offshore wind. This is really getting everyone a sound understanding of what the industry is about, what the challenges are, and the breadth of areas that feed into offshore wind. So everyone gets a broad picture of what the challenges are, and also training in research methods. You know, a PhD is all about your research project, but it's also important that you have the skills to deliver it effectively. Another aspect of that first year is about getting to know the rest of your cohort. Research isn't something that you do solely on your own. Very often it relies on working with lots of other people. And so building up that cohort activity together in the first year is really important. That also gives you a picture of what areas of research you want to do. And so when you get into your PhD, which can be in Hull or Sheffield or Newcastle or Durham, you've got a real head start in terms of getting out of the starting gate, getting a really quick progress into your PhD so you can maximise the time that you have available to you. In terms of the aims of the CDT, we really sought to understand what the challenges are for the key stakeholders within the sector. So that's industry, the general public, the environment. How can we make sure that all of those stakeholders have a fair input into the future of offshore wind? We've also worked closely with our industry partners, and they're providing some of the funding to allow us to do some of this research. And that's key, not just to do the research, but also to get it out into industry so that it really makes an impact. That can be through fully funded projects, or it can be through shorter term placements with industry to understand what the industry challenges are, but also to share the results of your research. So if we go to the next slide, please. So yeah, the first year of the CDT is a postgraduate diploma in offshore wind energy and the environment. That's delivered in Hull by colleagues from Hull, but also from Sheffield and Durham and Newcastle all contribute to this. And the reason that Hull is a great place for this is that it really is at the centre of this industry. Within a few miles of the campus, you have the Siemens Gamesa blade factory, where they're building some of the largest wind turbine blades in the world. And just across the Humber, we have the Ørsted operations and maintenance base for the east coast of the UK. So we really are at the heart of things in the Humber. Okay, I'll hand back to Danielle now, who can talk in a little bit more detail about some of these key aspects.
Okay, before we get into that, again, I'd like to share another video with you. If you could play that, please, Miriam.
The Aura Centre for Doctoral Training is your opportunity to make a difference. To tackle the challenges facing the offshore wind industry, to choose your own research path and kickstart your career, and to help create a sustainable, greener future for us all. The Aura CDT offers fully funded PhD scholarships to 75 students over 5 years. Starting in September of each year, new students join the cohort whose strengths come from the diversity of academic and working backgrounds, coming together to create a supportive learning environment. The Aura CDT draws on the expertise of leading academics from our 4 partner institutions. The centre is led by the University of Hull's Energy and Environment Institute, located in the Humber region at the heart of the UK's energy estuary. The Aura CDT works across 6 research themes with a unique dual focus on the engineering and environmental challenges. The broad range of research themes means we can offer funded scholarships to people from diverse academic backgrounds. We actively welcome applicants from all STEM subjects. We already have students researching in areas as diverse as wind and wave analyses to motion sickness in our offshore wind operatives. At the Aura CDT, we have made a commitment to train our students to be the future leaders in offshore wind energy and the environment. As an Aura CDT student, you will take a training year along with your cohort where you will develop skills that extend across the boundaries of engineering and environmental sciences. Knowledge at the cutting edge of engineering technology, and understanding of the life cycle of an offshore wind energy development, from conception right through to decommissioning. Tapping into the expertise of our partners, the training year is delivered by both our academic and industry colleagues. Following the completion of the postgraduate diploma, you will move on to a 3-year PhD research project. The learning journey continues throughout the full 4-year programme. At the Aura CDT, we value the student voice and strive to create a supportive environment. We are committed to creating a sustainable future for the global offshore wind industry. Join us and make a difference for yourself and the planet.
So I'm going to run through now the application and the selection process. Before I do that, I wanted to share with you the value that the Aura CDT puts into equality, diversity, and inclusion. Now, EDI is at the heart of everything that we do in the Aura CDT, right from the way that we promote what we're doing, from the promotional material that we use for recruitment, right through all the inclusive practices that we implement during the program. And we do this because we believe that diversity truly is at the heart of the solution for coming up with creative solutions for addressing the global issue of clean, sustainable energy. And you can see here on your screen is a photograph of most of the Aura CDT students that we've got on the program at the moment. And you'll see that there is quite a diverse group there, and that's a product of our recruitment processes. Through our recruitment processes, we've been successful with more than 40% of women on the program. We've got good diversity within our ethnicity and age, and you won't be able to necessarily tell, but we've also got a good number of people that are a welcoming number of people with disabilities onto the program. So if I can move on to the next slide, what does this mean in practice in terms of the application process? So we look to eliminate all bias as we can from the recruitment process, and that starts with the application itself. And you can access the application form and process through the Aura CDT website. It's quite a simple process. You need to download the Aura CDT application form. And you'll notice when you do look at that form that it's actually a self-blinding application form. So we have asked some very specific questions for information that we need to get past the initial stages of the sifting process. So you need to fill out that form exactly as it asks you. Do not include any personal information in that. You will also need to, as well as completing the form, upload transcripts and certificates around your academic success at the moment. So you will need to submit your application form through the university's application system. do not email your application to the Aura CDT email address. We won't be able to process it. So you need to go through the university website, application website, to submit your application form. So that's the application. Moving on to selection. Once we've received your application pack, we will then go through a series of steps through the selection. The first criteria of that selection is that you need to hold an undergraduate first class degree or a 2-1 undergraduate and master's or equivalent if you're an international student. The form that I mentioned before that you need to fill out will be used through the first stage of the selection, and that's through the double-blind sifting process. And in this process, what we do is we take your information, we give that application, blinded application, to a small panel of people that will then sift through that, evaluating based on subject knowledge, specialized skills, and written communication. Once they have shortlisted from that, you will then progress on to the next stage of recruitment. Now, the next stage of recruitment will involve an interview that includes a 5-minute presentation around what you can bring to your PhD if you were selected, as well as some industry knowledge, and again, we'll be looking at communication skills. Alongside that second stage assessment is also now going to be introduced a work group assessment. In that stage, we will be looking at how well you work as a team, your communication amongst your peers, and your problem-solving skills. So that group-based assessment will be, you'll be working in small groups, working through a short problem. They're watching you to see how well you progress through that and making an assessment on your skills. So once you've passed through the double-blind sifting, you've been interviewed, and you've also passed through the group work assessment, the panel will then take all of those scores and look to shortlist an offer based on that. So it is very important that you go through the university website, follow the instructions very carefully, and submit your application through the university website. So now that we've understood what happens in the recruitment process, if you are successful and to be recruited onto the program, you will start your first year as a PG DIP student at the University of Hull, and I will allow Nina now to tell you all about it.
Yeah, thank you very much. Yeah, so now we've heard about the CDT in general, we've heard about the sector and how it all fits together. So this part is really just to give you a few more details on the PG DIP, which forms a central component of the CDT and makes up our first year, so the training program you go through. So as you can see on this slide, the students that we recruit from come from quite a number of different disciplines, so we're normally quite a diverse cohort. That's normally good. That's good. So we see this as a strength. Offshore wind has huge potential, as we've pointed out, but obviously it also is a huge challenge. And so it's unlikely that it will be solved by a single discipline alone. And that's why we deliberately look for this collaborative approach and multidisciplinary approach, as you can see emerging from these different disciplines down the slide. So of course, at the same time, recruiting diversifully means we normally have a cohort with quite different skill sets, different interests, and if we want them to complement each other and work together, we need to put on a PG DIP that sort of fosters these skills. So that's what the PG DIP is about. We want to get you up to speed with sector relevant issues, fundamental technical skills, as well as soft skills, so communication, teamwork, things like peer learning, and then also the EDI principles, the equality, diversity, and inclusion that we've mentioned. So it's that's one of the key principles that we work on. So this is the structure of the CDT that you can see now. So you can see there's 6 core modules that sort of run through trimester 1 and trimester 2. One of them, the research project, sort of flowing into trimester 3 as well. And it's a mixture of things that are quite general, that give you an overview of offshore wind issues in general. And then there are some other modules that look quite specific, like you might see how they would want to sit in specific disciplines. That is, again, deliberate. So, and it's part of you taken a broad view of all the different skills that somebody might have in offshore wind. So we acknowledge and accept that different students with different disciplinary backgrounds might find some of these modules more easy to get through, more accessible than others. And so again, our mitigation, if you sit on a module that maybe doesn't correspond to your background too much, the mitigation is always that all of these assessments are based on teamwork, and we work through it collaboratively. So not all skills that we teach are relevant to all projects, but it gives you an overview of what other people do. You might still discover new skills that you might then apply to your own PhD, even when you haven't started, when maybe you didn't plan this in the beginning. So we've had a few cases like this in the past. And if not, then it still allows you to communicate more effectively once you do get to work in the offshore wind sector with people that are from different disciplinary backgrounds that may be applying certain methods. And if you understand a little bit about that, you can collaborate and communicate with them a bit better. The other thing, I guess, that's worthwhile pointing out, so we have a number of other things worked into this PG DIP program. We've got the residential meetings. We've got an annual Aura CDT conference, so that was early in the year. That was genuinely very interesting, so that's something to look forward to. And there's internship opportunities also worked in, and then also one of the goals of this first year is that you walk out of it with a PhD project in hand. So this first year also serves to explore different areas, talk to potential future supervisors, and really make up your mind what you want to work on, so that when you come out of it, you can hit the ground running. I think that's me. Yeah, super.
So it's my turn now, isn't it? So thanks, Nina. So hello everyone again. So what I'm gonna talk about is what are the partners of this CDT and the research themes across these universities and across this CDT and across the industry. So if I can have the next slide. Great. So in this CDT, we are 4 main universities: the University of Hull, the University of Newcastle, Durham University, and University of Sheffield, where I am based. And obviously, what you don't see here as well is the strong industry partners that they are sitting just in front and behind of these 4 universities, like Siemens Gamesa, Ørsted. And we came all together from different disciplines and different sectors, some of the leading universities in the sector, and we collaborated in order to bring forward these amazing opportunities in offshore wind. And you know, we all sat together with our industry partners and between all of us, and we in order to bring forward this amazing trip to offshore wind. And you know, when I say we, it's not like sometimes when the Queen says we, she means I. Here, when I say we, it is we. It's a teamwork, and you can see that in the next slide, where I'll talk about the themes and the research themes about the offshore wind. Now, offshore wind turbines, you know, are not some simple fans that they just rotate around. They're heavily complicated structures, and they're fascinating structures. And they're fascinating structures because you combine a lot of different disciplines and a lot of different research themes, and you blend them together. So you can look the physics, you can see the maths, you can see the data science, you can see the materials, because these wind turbines are unique in that perspective. You need to understand the aerodynamics, and there you go to physics, you go to engineering. You need to see the environment. You need to see when we employ these offshore wind turbines, do we cause any harm to the environment? How the environment in the long run will react into these offshore wind turbines? We need to see the materials. We have new materials, plastic, metal, how we combine this together, how we make them more efficient, how we make them cheaper and more competitive, and how we increase the performance. Data, digitalization, we're living in a different era. These structures have sensors. They give us data, how we combine this data, what this data can tell us, from the maintenance to the performance of the offshore wind turbines. And obviously, integration to the general environment, the grid, how we optimize the energy that comes out of these offshore wind turbines, how we store energy, how we use energy, and how we blend all the different other renewable energy systems together. You all heard about hydrogen, for example, and batteries, how we use this, how we blend them efficiently into the offshore wind system, and how we export energy further out. So you can see that offshore wind is a family of subjects, and these are all fascinating subjects that you can all, based on your interest, continue from your PhD research, also within the universities and with our industry partners. So I will hand over to Will, I think now, Daniel. Thanks a lot, all.
Thanks, Nikos, and that's provided a really good introduction for what I want to talk a little bit about, which is just a selection of some of the PhD projects that we currently have running within the Aura CDT. One of the things that makes the Aura CDT a little bit different compared to a lot of the other CDTs perhaps you've been looking at is that you don't actually select your PhD project at the point at which you enter the program. Of course, you have an idea that you want to do a PhD within an area, perhaps you haven't entirely nailed down exactly what you'd like to focus on. And during this first year at the University of Hull, you will actually then finalize the selection for your PhD projects. You'll discuss those PhD projects with academics from different partner institutions. And so hopefully I can just give you a flavor of 3 of the projects that are currently running within the CDT. But I do also encourage you to have a look at the web pages where you can see a list of all the different projects that are currently running within the CDT, and it will give you a good idea of the sorts of research that we're delivering. So if we go on to the first project, which is Niall is delivering this research at Durham University, and Niall's research is all about sediment transport and thinking about how that potentially impacts on things that we place on the seafloor. So obviously we install wind turbines offshore, they need to be supported by foundations, but we also install lots of other things within the seafloor, such as the cables that transfer the power and energy generated at the turbine back to land. And so Niall is developing sensors based on acoustic methods that can measure the sediment transport and the potential scour around these different infrastructures that we're installing on the seafloor. And that really fits within this physics and engineering of the offshore environment that Nikos was talking about just a couple of slides ago. But if we go on to the next project, which is by Rachel at Sheffield, also the University of Sheffield, I must get that correct. So Rachel's research is all about trying to balance what's perhaps seen as one of the downsides of wind energy, which is the intermittency, in the fact that the wind does not always blow, although actually based on recent experience in the UK, I think it does. But anyway, although it can be too fast sometimes. But, you know, wind energy doesn't produce this constant amount of power all of the time. And that's not necessarily an issue. But as we transition to more and more renewable energy on the network, then we somehow need to be able to balance this intermittency. And there are various different options to do this in terms of storing the energy in some way. And what Rachel's project is looking about is the co-location of the energy storage device, perhaps batteries, on the wind turbine structure itself, particularly looking at floating structures, and kind of trying to integrate this storage into the structure itself, looking at the feasibility of that, how to operate those that storage device in an appropriate way as well. And this very much fits into the wind energy integration theme. But if we go on to the final project that I want to talk about, this is a project that Ethan is delivering at Newcastle University. This is a completely different aspect of offshore wind, really looking at kind of added value that you can have alongside perhaps the conventional energy generation aspects of offshore wind. So Ethan's research is all about aquaculture, and so thinking about sort of development and processing of microalgae alongside co-locating that on offshore wind energy sites. These microalgae and its aquaculture is really important for various different industries such as pharmaceuticals, agriculture, and it's anticipated that these activities really need to scale up. And so the idea behind Ethan's research is, can you locate these sites for this aquaculture
down so quickly?
Wind turbine sites, but really he's trying to assess which ones would be most suitable, and also trying to understand the impact that those sites would have on the biodiversity of the surrounding environment. So it's not just is it feasible there, but what would be the consequence of doing that. And this again fits into a different theme, very much along the environmental impact, marine biology and aquaculture. But what you'll often find is these PhD projects cross over multiple themes. They're not just in one or the other. They'll have often a bit of a couple of themes. And I think again that initial training is really useful to help you understand those crossovers between these projects. So I think that's it from me. I'll hand you back over to the next speaker.
Okay, so I'd like to talk a little bit about the way we work with the offshore wind industry, because the industry is growing very rapidly, but it needs help in that growth and in understanding the impact that that industry has on the environment. And so we work very closely with a range of industry stakeholders to try and make sure that our research is relevant to the industry, but also it gives us a path for our work to reach out to actually have an impact. So next slide, please. Okay, so we work with industry in lots of different ways, and each project is different, ranging from projects where we work with industry to define a project and they maybe sponsor it because they really want to be very closely involved in a project that's really solving a specific problem for them, and I'll give an example of that in a moment. But lots of other ways of working with industry. So some of our students have secondments working in industry or in other organisations, really understanding how these different organisations work to develop offshore wind, but also how their research can have an impact. Quite often we work with industry and again other organisations
of this massive industry.
As we'll talk about in a moment, offshore wind involves some huge facilities, and none of the universities anywhere in the world have the scale of facilities that the industry is now installing. But by working with industry, we can get access to some of that really unique equipment. Another thing that's incredibly important for research is data. And again, it's very difficult to generate that data synthetically. But if we, by working with industry, can access current data and the understanding of what goes behind it, because often you get lots of data and it doesn't really mean anything unless you know the context. So working with industry, getting the data, understanding what it means, and then how to present the results of that analysis so that it's usable by data, by industry. And quite often we have industry advisors on our individual PhD advisory boards. So they often come with a slightly different perspective to the academic supervisors, and that balance between the academic perspective and the industry perspective really makes for a strong PhD. And we often have industry lectures. So our industry partners are very keen to interact with the students to understand where future talent lies. It's an industry that has a very quickly growing demand for skilled personnel, and by working with us, it gives our industry partners a chance to interact with potentially future employees. And so these photos are just an example of that. This is our most recent CDT conference. Bottom right, we have Siemens Gamesa's head of business development talking about the opportunities in the industry with an image of the whole blade factory in the background. But all of that CDT conference, there was lots of interaction between the students and representatives from the industry. So next slide, please. So the next slide is talking about a specific project. So this is actually a project that I supervise, working with Siemens Gamesa Renewable Energy around improving the manufacture of wind turbine blades. As you'll already be aware, wind turbines are huge structures, and the blades are getting bigger and bigger all the time and very rapidly. So currently blades are being manufactured at 80 meters, but already going into production 100 meters, 120 meters. What that means is that each blade becomes bigger, heavier and more valuable, and it becomes increasingly important that the quality of that blade is maintained and improved, because there's always pressure to reduce costs. Not only are these structures very large, they're also incredibly strong. You know, the forces on a wind turbine blade come to tens of thousands of tons, and so they have to be incredibly strong. So what Oliver's doing is understanding the real detail of how they're manufactured by putting resin into glass and carbon fibre reinforcements and making sure that resin flows everywhere, so that every part of that blade is as strong as it possibly can be. And so Oliver's spending time in the whole blade factory. He'll also be going to Aalborg, where these blades are designed, to really understand what the industry problems are. So hopefully that gives you an idea of the kind of industry interaction we have. Following on from this, we'll talk a little bit more about what the student's perspective of the CDT is. So if you'd like to go to the next slide and run the film.
The Aura CDT is a PhD training program in offshore wind and the environment, when you'll not only become a subject expert in your particular discipline, but also get a broad education across all aspects that are relevant to modern offshore wind farms.
Hull is in the centre of the Humber Estuary, and the Humber Estuary is an absolute epicentre for all things renewables. It is known as the energy estuary. This means for you studying at the University of Hull, you'll also get the opportunity to really get out and see what this looks like on the ground.
There is no better place to research offshore wind than Hull. It's right in the center of offshore wind sector, with numerous wind farms located just off the coast and very strong connections with sector-leading industry, such as manufacturers Siemens Gamesa Renewable Energy, who have their blade factory right here in Hull, or Ørsted, who operate the wind turbines from their facility just across the estuary.
Being within the Energy and Environment Institute has also been really great. Being constantly surrounded by so many postgraduate researchers and lecturers with such a broad knowledge base and a wide variety of fields. I look forward to completing my PhD and to having a career within the research industry and helping towards a more sustainable future.
We have been able to work with Siemens Gamesa graduate apprentices. They were in some of our lectures in our first semester, so working with them means that they were able to give us the practical application, and we could kind of give a little bit more of the theory, which together balanced well, and we were able to work very nicely together. We've also been able to pitch our PhD topics to industry and kind of tell them how we're going to be helping them, and they can then input in how they might be.
You know, as you've seen, the offshore wind
or any facilities that they may be able to give us to make our PhDs better and enhance the research that we are doing.
The demand for renewable power generation in the future will only continue to grow, and for you that means that the career prospects in this industry are always going to be in demand. All of these different aspects come together to be able to make this happen, and you could be one of those people.
So that brings us towards the end of the summary of the webinar for tonight. You've heard all about why we're interested in offshore wind. You've heard all about how to apply for the programme. You've heard about the structure of the first year based in Hull and some of the research projects that we've got running at the moment. You've also heard how we work with industry. So I think that pretty much wraps up everything that we wanted to share with you this evening, and I'd like to now take in the last 10 minutes or so some questions from yourself. So we've already got some questions in the chat box, and I will just open up those firstly. If I could actually ask all of the panelists to turn their cameras on so I can direct the questions to the right person. Hello, hello, hello. Okay. Okay, so first question we've got here is a really good one, actually. The attendee is talking about how they've got quite a different background to a traditional academic route, and how do they fit in then with the CDT through the recruitment process? And perhaps I could ask Nina if she's there to, can't see her on the screen. Nina, if she wouldn't mind answering this question as part of the recruitment process. Nina. Okay, in the interest of time, I will ask someone else to answer that question if I could. Will, would you mind answering this question? If someone comes from an industry background or something not through the traditional route, how would they go about doing their application?
I mean, I think that's really where the double-blind application comes in, that you're outlining your skills, your expertise, your desire to join the program without, disclosing exactly your background necessarily. We're not collecting information that would perhaps allow us to easily identify people with different backgrounds in the way that we're asking for the applications to come to us. And that's, I think, a real benefit. And we've seen applicants come to us with a really diverse background, including people that have worked in industry for a number of years and then chosen to pursue a PhD in this direction. So it definitely shouldn't put you off applying. And if you have a look at the form we asked you to complete, it's all about why you want to do this and why that's the next right step for you, not necessarily where you've come from, although obviously that has informed the decision you're making now to think about studying for a PhD. So definitely don't let it put you off applying. We really welcome people with different backgrounds to apply to the program, and you'll add a huge amount of value to the cohort in terms of having that different experience and being able to impart that experience on the rest of the students on the program, particularly as part of that first year in Hull, where you've been in lots and lots of group work, and that's where these different experiences are really valuable.
Okay, thank you, Will. So we've got a few questions coming through around the eligibility criteria. So if you, and I think I can probably answer this question myself if I may. So there are people asking about, if I've got a 2-1 and a master's, is that okay? Yes, it is. You are eligible to apply. Equally, if you've got a first, you're eligible to apply. If you are an international student, what we will do is look at whether or not you have the equivalent degree. So you shouldn't worry necessarily if you've got an international degree, that's fine. What we will do through the admissions team is have a look at whether or not it's an equivalent degree. We've got some questions also around, again, if I've worked in industry for 16 years, am I eligible? I think, Will, what you're saying is yes, we're certainly interested in that because we're looking at diversity there. Oh, we've got someone who, if someone has not completed their undergraduate but is on track for a first class, are they still eligible? Yes, you are. What we will do is give you a conditional offer if you make it through the recruitment process. Based on your grades, we would expect you to get your first class. However, your offer would be conditional.
Daniel, can I just add that when we say 2-1 with masters, so there's no confusion, an MEng with a 2-1 is also considered obviously an undergraduate with master. So we're not expecting a separate master from an MEng degree. Just to be clear on that for all of you. First class, I think we're referring more to a BEng rather than an MEng.
Okay, thanks, Nikos. That's a really, really important note, because I think looking at the questions, we've got a number of engineers that are attending this evening, so really important to understand that. How does closely your degree experience match to the research themes that you're interested in? Again, can I ask will have already asked you. Jim, do you want to comment on this? So if someone's, again, coming from a different background that hasn't necessarily been listed and doesn't look like it naturally aligns to a research theme, how do they fit in?
Okay, so I think, you know, PhDs are very individual, and to some extent you create your own PhD. So if you come in with a qualification that isn't maybe obviously sitting within a particular field, what we would do is look at your experience and how it maps to what's required for that particular PhD, and try and work with you to find the right project for you. So you know, one of the benefits of having that year to decide on your PhD project is you get to understand what the real challenges are within different areas of work. So you might think that, you know, although you don't have a background, say in computer programming, that's something that you want to get into. You'll have a chance to explore that, and it may be that is really what you want to do, or you may decide that it's not what you want to do. And so that year allows for you that flexibility to see whether your experience and aspirations line up with the work that you want to do.
Thank you, Jim. We've got someone asking whether or not we offer the part-time study option. Yes, we do. We have students that are already studying part-time, so that is not an issue. A question for the students: how did you select your PhD project? And if I could ask, not you, Victoria, because you're an industry student, you've already got a project. Maisie, did you want? Oh, actually, are you able to talk, Maisie, given your voice?
Can I ask you? Talk. That's fine. Yeah.
Okay. You and Daniel don't mind speaking to this one. That'd be great.
No, that's fine. So for me, originally I chose one, but two of us did want the same project, so we came up with a different one that was also working with industry as well. So it actually worked out quite well for me that there wasn't one, and that we had to almost find one and create it in a way that I would then want to carry it forward. So it's with industry as well, but not the normal route of industry. So it was just a bit later that I decided on what to do with mine.
Daniel, did you want to say anything to that?
Yeah, so when I chose my PhD, I knew quite from the beginning what I wanted to do. It was definitely something to do with like nanotechnology and physics side of my research. But when it came to like choosing the project, I had an idea, so I went to Danielle and the board and basically said, this is what I want to do. And they took that into consideration. They found a project that worked and that worked with the ambitions of Aura, and that's what I'm doing.
Thank you. We've got another question here around what are the software skills required for next generation material theme? Who's going to be best to answer that one? Nikos, is that you? That's going to be more yours, is it? I'm going to give it to you.
No, I am. I'm not like Brian Cox that he answers everything. So I don't know a lot about materials.
Of course you are. If any of the other panelists could one of you volunteer to answer that question? I think the answer simply is, depending on what project you want to do, you need to have some background in it. Will, would you like to take that one?
Yeah, I can come to the rescue slightly there, although perhaps not comprehensively. I think it's just highly project dependent, and apologies if you can hear small children in the background of my house. It's just highly project dependent because the question was about what software skills, as I understand it, unless I've misinterpreted the question, because it may well be that you're doing a project which is in materials related, which is almost entirely experimental rather than you know, computational or analysis based. So it really, I think the message coming from the students is that we try and work with you to identify suitable projects, that when we're doing calls out for projects, we provide the academics with information about the cohort so that they know if it's going to be appropriate or not to pitch their PhD idea to that group of students. And then if we find there are projects, you know, no particular projects that really interest the students, we've done this a number of times, we've worked with the individual, identified kind of the appropriate academics, and then developed a PhD proposal. So if your background doesn't align to a particular area, don't worry, we will work with you to find the appropriate project, provided it's on offshore wind in some, you know, related. Obviously, we can't do anything.
And just to add quickly that don't think about softwares. Just think if you like the PhD you're gonna do, and if it aligns with your studies and what you want to do. Softwares are irrelevant for your PhD. You will learn this as you will start your PhD, so it's part of the journey. So don't think what software I need. Just think, do I like to do this PhD or not? And I think that's the most important part.
Absolutely. Now, I think we're almost out of time, but Dan, did you want to make any last comments there before we close out?
Just to thank everybody, in particular Victoria, Maisie, and Daniel as well for coming along. Hopefully everybody's got a flavour for what we offer and the broad base of the CDT. And if there's anything that either if you're watching back or you've not, you know, you think about after the call's finished, do get in touch with us. We can respond and come back and answer any further questions as well as we move forward. But thanks for attending, everyone, and thanks to all the panelists as well.
Okay, thank you very much. Have yourselves a lovely evening.
Thank you. Bye.